All right. Thank you, everyone, for joining day 3 of this year's spring meeting. We've got some really interesting topics that are going to be covered today. I'm going to start with just some housekeeping items before we get started. So today is Wednesday. We're going to start off with a presentation by David Wright, talking about GPT and actuarial exams. And then at noon, we'll have a presentation from Sally Ezra and Eliana Schechter about counteroffers. As we've been showing the past couple of days, this is our antitrust disclaimer for this meeting. Please review. And just a couple other items. So the same as the last couple of days. So if you think your email is out of date with the club, please let us know. So we have the right contact info to reach out for our meetings each year. Please stay muted and have your video turned off during the presentations. Utilize the chat box for questions for the presenters. And then any technology questions, please message Richard Wu or Kathleen Swain. And David, I'm going to go ahead and pull up your presentation here. Let me get that going. Okay, let me introduce David really quickly. So David started his career in reinsurance as an analyst and producer at Actuarial, eventually managing the sales and operational teams in the New York region, and as an actuary, led the analytics teams across in North America. David was part of the founding team of an AI insurtech startup, Altway, staying with the team for a couple of years post-acquisition before assuming his current role as market solutions leader for Actuarial, managing complex placement and program development projects and the largest external wholesale relationships. David received his bachelor's degree from Queen's University in Canada. Thank you very much for sharing with us today, David. All yours.
Thank you. So we can maybe skip this. I will make a little personal plug, if you don't mind, but the Not Unreasonable podcast, which is something I've hosted for several years, and where I explore all sorts of interesting insurance adjacent and directly applicable issues to insurance, released irregularly. Most recently, I have not been very productive on the podcast because I have, like many others, been totally obsessed with GPT and trying to figure out what this is all about. The next slide, please. The way I've been trying to approach this problem is very much trying to understand it on an actuary's terms. I think a lot of what we see out there are people getting very excited about applying GPT technology to other domains. So to writing for a living, perhaps, or to coding. And I know a lot of actuaries are programmers, and myself, Moonlit is a programmer here and there. But these are not kind of striking at the heart of actuarial problems or insurance analytical problems. And that's the domain where I feel most comfortable and most expert. And so I wanted to give this thing a test in the area where I am most able to assess its strengths and weaknesses. And so what I've done is I have given GPT a series of actuarial exams. And I saw the title of this talk was fails the final actuarial exam, which it did for the CAS. But I'm going to focus in this talk more on the ILA-LAM exam for 2019 that I also gave it, and haven't published anything publicly online about that. And the idea is here to go through some of the questions and answers that I gave GPT. I gave it the entire exam, and it failed the exam. And I'll talk a little bit about how bad of a failure that was, and you can interpret for yourselves whether you think that's impressive or unimpressive. From from these questions, we will be able to infer some of the principles of the limiting factors on GPT, and also some of the principles that lie behind its success. It scored very well on certain problems. And I think there's some patterns there that we can take to imagine where this technology might go. There's a whole bunch of things we might do, or things we could try to mitigate some of the problems of GPT. I think some of its weaknesses are very easily mitigated. And I'll walk everybody through a few experiments that I've been running to try and overcome some of its limitations with some success. And then we'll have some time for Q&A at the end. Next slide, please. I'm not an expert in LLMs. I've worked with some people who are large language models, and maybe most of the folks here have sort of been not living under a rock, maybe, and have heard about these things, these AI models that have kind of taken certain corners of the internet by storm. Here is a comparison. This is something I found insightful in trying to understand what it is that is so interesting about these models. And this is a comparison between two different kinds of language models. The one on the right is called BERT, Bidirectional Encoder Representation from Transformers. Much jargon, but that acts as more of what we might anticipate a language model to do. It takes a bunch of text and it trains that text on certain kinds of label categories. And so later on, when you hand it the text again, or hand it text in a production environment, it will then give you labels. It will tell you, well, this is an organization that is Apple, right? So it looks at the text as Apple Inc. decided to look at the table there, the fourth row, Apple Inc. in Austin, Texas, and it says the city is Austin and the organization is Apple. I saw a question in the chat there asking what a transformer model is. Getting a little bit outside of my domain, and I suggest you probably look that one up. I can kind of give you a basic idea, which a transformer model is something that takes a language, it will translate it into tokens, and then it maps those into something called an embedding space. So it doesn't, again, technicality here, dimensionality reduction. And so it tries and simplify all the variation that's possible in text and create predictive patterns off of that. But not, an amazing thing about these models actually is that you don't need a very deep technical understanding for how it's built in order to explore what it is. It is actually something that is of concern to a lot of people, that nobody really understands what happens inside of the neural network that comes out of this. There's billions of parameters. They'll say hundreds of billions or maybe even trillions of parameters. Who knows what GPT-4 has? And so it's pretty hard to conclusively determine kind of what's going on inside of the model. But that also unlocks the ability to experiment with it for people who don't have a hope of understanding what happens inside the model, because you don't need to understand, or you cannot. Anyway, so back to the table here. GPT operates in different manners. So we have this classification system, which is kind of what BERT does. And GPT actually extends out the text. So it will predict what the next word is in a whole bunch of text. And it can then write as a result. And being able to write coherent, well-written sentences is GPT's superpower. And the extraordinary surprise that has come about because of this is actually us discovering how much of our reasoning ability is presented and represented in the language that we use. So it looks like GPT is actually intelligent because it can write well, and it can write very, very well, which is not something that another language model like BERT, which is concerned more with classifying things, actually even tries to do. So a little bit of a concept of what the breakthrough is in large language models there. Next slide, please. So the point of this slide here is to describe for folks who might not have seen this, or how aware you've been of this, of why I'm even here trying to do this. I saw this chart on Twitter, I think, or something a few months ago, which shows the scoring, so how GPT scored on a percentile basis on a whole slew of standardized exams. And the blue line there is GPT 3.5, which was the original ChatGPT release. GPT-4 is in green, which extends some of the capabilities. Not all exams were tested in this set. This is incredible, right? I mean, you see some mathematical exams, some technical exams. You see it not doing very well on some literature exams, just super surprising. There's all sorts of interesting things that one would want to dig into here. I was not able to find any paper that digs into the methodology of how these exams were administered, how the grading was done. Obviously, since I was set about administering exams at GPT and grading them, I was really interested in understanding how I might be able to do that. I couldn't find any documentation on that. So I'm not sure exactly what their methodologies are. And I'll talk about or what I did anyway. But the idea that you have an exam here that can pass, really crush certain standardized exams, the LSATs, the SATs, certain sections of the SATs. I mean, what is its potential is really what the mind wonders, given that it can score in 90th percentile a whole bunch of pretty challenging exams for humans. Next slide, please. So here's what it did on the actuarial exams that I've administered. So I've done 3, and thanks to Robert Eaton, who's an actuary that helped me with the ILM LMA exam, and my rough scoring of that is about 50% of the passing grade. And I'll be publishing the material on this and the example exam on my blog at notunreasonable.com in the near future. So you can decide for yourself whether you think that's a decent pass. I'm not sure what the distribution of scores are for this exam or for this exam. On the CAS exams, you have a little bit more documentation of what the passing grade was and a little bit of information about the distribution of scores. And I would say for CAS 9, which is the last exam in the CAS curriculum, 42% of the passing grade probably puts it around the 50th percentile, maybe 40th percentile. For CAS 6, CAS 9 is capital modeling and insurance rate of return analysis, financial rate of return analysis. CAS 6 is regulation, history of regulation, accounting, these kinds of topics, which are much more in GPT's wheelhouse, which we'll discuss. And it, basically passed. I mean, not exactly a passing grade. You can quibble on some of my choices for scores, but did a very good job. And we'll be talking a little bit about where its strengths and weaknesses are. And CAS 6, I knew was always going to be a bit of a layup for GPT, playing to its strengths. These exams that have more quantitative questions are a little bit harder for it to score well. Next slide, please. Okay, so right into the questions. Okay, so ILA, LAM 2019. And I picked that exam because later exams have a bunch of spreadsheet work in them, which is harder to translate for a model. Practically speaking, how do you get information into the model and out? So these exams are all in text on a PDF, which you can copy and you can paste. And I use the API, backend API for GPT-4, and I was able to just send all the questions over and it gave me all the answers back. So it was a very simple way to administer the exam for it. We're going to start here by picking on GPT a little bit. And it did very poorly on certain math questions. And here's an example. And in most of the exams that I gave it, this is about, of the exams that I gave it, this is the worst math answer I got back. So the question here is, how do you value the guaranteed minimum annual interest? Value the guaranteed minimum annual interest feature using put call parity. So you want to value the put here. And in this case, it actually formulated the problem pretty close to correctly on the left-hand side of the table. It should have included the guaranteed return first on the $2,000 and then discount that back. But that's not bad, right? And then it proceeded to mangle the algebra, and who knows what it was thinking on the right-hand side of how it turned this into that mess. But it's incorrect. And purely because of the calculation errors. It can perform arithmetic, GPT-4, that is. An earlier version, GPT 3.5, had a lot more errors in its arithmetic. GPT-4, for the most part, can add and subtract and multiply and divide. And I think we'll be talking a little bit more about that later on here. But this concept of algebraic manipulation, moving things from one side to the other of an equal sign, it's a little bit too much for GPT, I guess. So that's one problem. And on 2C, same question 2, but on part C, with calculate the surrender value of GPT. And actually go to the next slide, please. So here, which is the same problem as on C on that prior slide, we actually have another formulation of the problem, which is pretty close. So the solution to this requires applying a cap and a floor. It only, in its formula here, it only documents the cap, but it actually applies the floor, strangely. And it missed the guaranteed rate impact again. So it applied the floor somewhat correctly in the, well, actually applied the floor correctly. If it actually just processed the calculation of that surrender value 1, that first line there, it would not get the answer in part 2. But if it processed the calculation with the cap and the floor, which it didn't show it was going to do, but it did, it gets the answer that it gets. So it's almost like it got the right answer for the wrong reason. It didn't follow its own math, but then it actually came out with an answer that was appropriate. And then it missed this problem with the guaranteed rate, which would have changed the $2,000 there into that $2,000 times whatever guaranteed rate would be. So kind of close. Very weird method or mode of failure here, which is strange. The question asked for the surrender value for each year, and so you have to carry this forward into the second year of the policy. And here it just carried forward the answer from the surrender value 1 policy year 2. So the 1900, you'll see that's the same in these two problems. That's wrong. It should have used actually the $2,000 with the times the guaranteed rate impact. So otherwise, the same errors, right? So that shows, again, this formula, which is correct, but then it doesn't have the cap, so it doesn't have the floor applied, doesn't have the floor demonstrated, but then it applies it. What you're kind of seeing here are the beginnings of the clues for some of the challenges here, where actually grading these things is very tricky, very hard, because it kind of comes up with answers that are super close to something. They're like highly plausible answers. Some might call that BS, and ChatGPT or GPT generally, let me not mince words, is a masterful BS artist. And then when you have a BS artist giving you math answers that look really good, are they right? Or how much understanding is there embedded in this answer? Even if the final answer is not exactly correct, did they really understand what's going on? That's really, really hard to assess. Next slide, please. And we're going to talk more about that difficulty as one of the problems to solve for GPT later. So we're going to go back and do something. We're going to go into GPT's wheelhouse here a little bit. And this is actually against a pretty high standard. We're judging it. So here the question is, describe 4 assumptions required to value that EIA product under a risk-neutral stochastic framework. And from the grading rubric and the PDF that I had there, it told me that the candidates performed poorly in this part of the question. And they didn't apply the risk-neutral framework to the product. So they had to integrate 2 topics here. So one was an analysis of the product, and another was applying the risk-neutral framework. And so you have to mix up the assessment between these 2 sort of conceptual spaces. And GPT did really well, actually, which is now impressive because we're told the candidates did not. So next slide, please. And here's like an example of its answers. And so on the left, we have the grading rubric, and on the right, we have GPT's answers. And so I'll go through this a little bit. It's a little bit challenging sometimes to sort of describe these in a presentation because I wind up having to read text at you, but this is a text generating algorithm, so we're gonna have to read some text here and there. So risk-free rate of return is the first thing we need on the upper left, and GPT correctly described risk-neutral pricing. Lapse rates are an important factor of analysis, and then GPT policy holder behavior includes surrendering the policy or lapsing the policy. GPT, so index volatility, and we have index return behavior, and then there's an other category for the answer, and then GPT kind of goes back to this risk-free interest rate process, the risk-neutral pricing, which I'm saying doubles up, so I didn't give it credit there for that one, but that's pretty good. I thought, and so I give it, whatever the right amount of marks would be for that, like, 3 answers out of 4 correct, which was a pretty good response. Next slide, please. So back into criticizing GPT, where this is something that it was really bad at, which is swaps, and in particular, determining the cash flow, the direction of cash flows. Now, swaps, especially if you get into sort of international interest rate swaps and things, can be a real headache for all of us. And man, GPT did just totally face planted on this time after time and time again. Some of these questions, after getting the kind of the formal answer, I was sort of wondering, how much of this bad answer or a good answer was random variability. And so I would give the question again and again and again, just to sort of see how GPT's answers might change. And I did this for a whole bunch of times on this just because it was so bad, and it never got this cash flow thing right, which is amazing. So the basic idea here is you have a 10-year bond yielding 4%. So the insurance company is getting 4%, and it pays 3% to a swap, and then it gets back LIBOR, and then it pays LIBOR plus 50 basis points to a policyholder. Great, you're making 50 basis point coverage margin between the bond earnings and then the paying out the policyholder, which is a 50-point fixed override over LIBOR. So, it's a decent product, right? Next slide, please. And GPT got the cash flows backwards. So the upper left-hand side here is my depiction of the flows here. And GPT, for some reason, thought it was receiving fixed interest and then paying floating to the swap, and then receiving fixed back and then paying floating to the customer. So GPT is like, oh my gosh, this is a terrible idea because we're exposed to all this interest rate risk. And it seems like no matter how many times I tried to get it to understand that this was wrong, it just wasn't unable to kind of process this concept of making a margin after hedging the risk of the variable or the floating interest rate. Very weirdly, so given its quantitative failure, then you go to the narrative and it's saying, explain what happens, right? And it actually correctly describes what it's supposed to do. So it says, use interest rate swaps to protect yourself against the interest rate risk. And this is like almost like the purest sort of a distillation of what GPT is good and bad at, in a way in which it's good and bad. On the same question, it can describe what it's supposed to do, but it can't actually do it. And once you get into the weeds of the mechanics of actually how you implement an interest rate swap, GPT just sort of falls apart. But it does understand, and whatever meaning that is, that an interest rate swap is the solution to this little risk management puzzle. So what do you make of that? Next slide, please. Okay, so we're gonna dip into the CIS Exam 9, just because I think this is another example of something GPT is really strong at, and hopefully the domain doesn't translate. It translates okay for everybody here. In CAPM, which isn't even an actuarial concept, right? It's financial markets. One of the things that popped up several times in that CAS 9 exam are questions about CAPM, and man, this GPT. No CAPM. So there's all sorts of really interesting concepts here that GPT was very good at understanding. We have a covariance matrix for different stocks in the market. We have a risk-free rate. We have the usual CAPM kind of formulas. And the questions are: calculate the expected return of the market, plot a security market line. GPT does not have graphical capability, but it can describe the plot. And it did a very good job of that. And then there's this question of the portfolio manager recommendation, using a utility function, and it has formulation of the utility function there, and it's saying, what do you think you should do? Next slide, please. So on this one, GPT understood the CAPM formula and understood the concept of beta, this correlation between the asset and the market, and understood the security market line. It drew it in words correctly. It understood the concept of utility function and was able to calculate the utility function using the information provided and interpreting properly the utility function. There's a quirky formulation of the market price of risk, which sometimes I've found anyway in the CS exams, maybe folks find the same thing, where the exam drafters will kind of throw a curveball at you, a familiar concept, but ever so slightly different kind of way of putting it. And then, you sort of don't recognize the term all of a sudden. So I'd say that GPT got tripped up on that slightly unfair trick, I would say. So, I docked it a mark for that. And I would say, given my analysis of it, I could have given it, maybe another half mark than I gave it. And, the idea here, concept that the reason why I bring this one up, the concept I want to drive home for you folks is when there's a lot of information online about something, and probably every finance exam ever written has a question on CAPM. It's just such a tractable body of theory that is great for exam questions. It's simple, it's easy to implement, it has some advanced concepts. I did the CFA exams once upon a time, and it's just sort of like there's so much information online about CAPM that those are just absolute total layups for GPT, and it can handle CAPM questions very well. So the point here to make is, to the degree that there's information online available that can train this model, it can wind up with a really nuanced and very sophisticated understanding of the model, including all kinds of edge cases, because lots of exam writers love to give us tricky CAPM questions. In this case, we were able to trip one up, but CAPM is a source of strength for GPT. Next slide, please. Okay. I love this question. This is my favorite exam question I think I've ever seen. So big kudos to the 2019 ILA-LAM committee for this one. So this is a company runs a stochastic model and compares it to a deterministic model. And the stochastic estimate is 35. Is that right? Yeah. I actually might have miscopied this. I thought the stochastic was the 105 and the deterministic was 35. In any case, big gap. Right? That doesn't matter so much. There's a massive gap in results. So you measure the same thing two different ways, something I always tell my analysts to try and do. And if you get really different answers, you either made a mistake or there's something going on inside of here that you need to learn about, right? And in this case, the right answer to the question is that you made a mistake, which I just love. The kind of sort of breaking the fourth wall almost on the exam is saying in real life, if you have big divergent answers, you actually wind up with an error somewhere. So you go find the error. And that's what you need to do to tell or to write down in order to receive full credit on the question. And GPT did not, in the first answer that I gave it, pick up on that nuance. And that was very interesting. Now, so it played the question straight. It gave you the usual reasons why stochastic models would diverge from deterministic models. It would say, oh, there's some edge cases, there's some rare events that get incorporated in the stochastic model, which maybe can surprise you with how much they influence the mean result. And these are all the normal things, right? And this one, you're getting a little clue to my bias here, what I think GPT is good at. I sort of had the feeling that maybe this is something that GPT could pick up on, is questioning the validity of the approach, of the strategy. It's a pretty sophisticated thing to do, right? And I gave GPT this question several times, like 3 or 4 times, and looked at each answer. And it actually picked up on the possibility of what's called miscalibration. When that word, I think exactly that word is included in the grading rubric, it picked up on this about half the time that I gave it the answer. And so this is, and it even kind of evolved even further. So I'm going to read this example. So this is from GPT. So if the stochastic model's assumptions are too pessimistic or include many low probability, high impact events, you might underestimate the surplus. It's crucial to validate and calibrate both models using real world data to ensure they're providing accurate and useful estimates. So I'm saying that, the next one is their discrepancy also indicates that BWI should reconsider the assumptions in their deterministic model, which was amusing to me, because why does the stochastic model have to be the source of error, right? So and perhaps this is something the grading committee would have given credit for as well, because you can question the premise on the stochastic model, or you can have an error in either model, right? Or you can misapply either model in some way. And GPT actually picked up on the possibility of the deterministic model being wrong, and much, or the stochastic model as well in a different version of the answer. So I think that this is a clue actually to the depths of sophistication you can get with GPT, albeit with some variability, right? It didn't actually hit this one every time, but I think usually, I think the ability to actually question the premise of a situation, the ability to actually think about the underlying assumptions that lie before a question, I think is a really sophisticated level of analytical insight, and I think exactly what you want an actuary to do. Right? Next slide, please. So this is another really important kind of like commentary on the life of somebody who's giving exams to LLMs, which is that they are tough to grade sometimes, because you wind up with very different looking. You think of when you're a candidate, you've read the body of material, and so the way that you expect candidates to kind of, let's call it, regurgitate back that material to you as a grader is usually going to look a lot like the original material, right? But GPT doesn't only study actuarial material, although it probably does a fair bit of that. It studies other material, and a lot of the concepts overlap with other domains. And so the way that GPT will express things sometimes is in a way that is a little unfamiliar to, say, let's say, the pure actuarial formulation of an answer or a concept. And so you really have to think hard about these sometimes and scratch your head and think like, is it talking about the same thing or not? Does it understand, whatever that means, what we're trying to get at here? So with the comparison between cluster modeling and replication techniques for reserves, we kind of come to this problem where, which one's better? And so you kind of have these key words here that GPT doesn't use, like cluster modeling uses a function to be optimized under a set of constraints. GPT doesn't use that word, but it kind of comes at the concept saying that it involves calibrating reserves to a model policy to match the reserves of a set of actuarial policies. Is that the same thing? I kind of said, yeah, I think so. Both models, and so that's the top one and the bottom one. It has this word compression, right, which is like another trigger word, right, an important word in the kind of the concept of what we're discussing here. And GPT talks about computational load and whether it captures the full complexity of the policy portfolio. So it kind of comes at it indirectly. I gave GPT marks for these two, which is debatable. But there are other instances where you start analyzing a question and you realize it's just total garbage. Like there's nothing here. This isn't what is this tool they call it hallucination, right? And I don't know if I have an example of hallucination here. I probably should put one in this presentation. But you sort of read it carefully. You try and trace its logical steps. Often it does this in math, and you realize that there's nothing here. This doesn't make any sense whatsoever. So you give it a 0. And those are very disappointing because I'll have had to invest a fair bit of time to get to that point in grading these exams. Next question, please. Next slide, please. Okay, so here we're going to start summarizing things and talking a little bit about things that I've done to see if we can overcome some of the problems. So one of the things you will read if you look into these things online is the context window is a limiting factor. You can only hand GPT something of the order, at least in the version that I have access to, 4,000 or so characters, which is a certain number of tokens, and that's the limitation of its bandwidth of how much it can actually read, understand, in order to extend the text further, right? So there's like a bandwidth limitation of how much information you can put in and get out of the model. In some contexts, that's a big problem. But in the actuarial context, I have not seen it be a very big problem. These questions tend to be a fairly limited number of tokens. The responses are a fairly limited number of tokens. I think generally speaking, actuarial work is kind of more of a small to medium sized data set work. I mean, there are definitely exceptions to that rule, but usually you're looking at already an abbreviated set of data that you're making decisions on. That more than is the context window that we have available right now is more than enough. So I haven't found that to be a limiting factor. Put it up there because it's a very popular one to discuss. Where we get into things that do matter, we have the limits to training. So I'm calling this the cost of verifying complex output. When you have training some kind of machine learning model, you need to have a cost function, right? So you need to have some target you're trying to hit, and you have to validate whether you hit the target or not, or how far away you were from the target. Actuarial exams are not easy or cheap to evaluate. You have to look at it very carefully and read the stupid thing and understand it with some domain expertise, maybe a lot, to see how close or how far GPT is. That's a very expensive training process. It makes it hard to experiment with techniques. So if we came up with a whole bunch of really interesting and valuable ideas for expanding GPT's capability using prompt engineering or other things, we'll talk about that. Let's say you have 1 million ideas, or you have a couple parameters in which to vary a couple of ideas, which can give you 1 million examples of different ways to tune this model. There's no way you could actually implement that because you don't have a way of evaluating whether you succeeded or not. without then getting an actuary to spend 15 minutes on every question to see whether or not it was correct. So it really gave me an appreciation for the miracle of GPT as something that we get all this intelligence simply by having it predict very simply what the next word in a sequence of words is. And if you have a long enough context for that, you actually infer some very sophisticated models for communication, which in turn imply models for decision-making and understanding. And so, the breakthrough GPT is that this very simple cost function, which is, did you get the word right, actually gives you all this understanding. And so it's, actually incrementing on that in some way for directly measuring the outcome of very sophisticated analytical questions requires unfortunately, very sophisticated evaluation process, which limits how much experimentation we can do. So the next interesting concept, you folks, if you've been paying attention or following this kind of thing, you'll have heard of prompt engineering as the next kind of great skill for humans to try and learn or develop for themselves. I think of this, the way I sort of visualize this, and I played around a fair bit with it, is you kind of this, like, let's call this like mass, this sort of cloud of knowledge that is GPT's capabilities, right? And if you ask it sort of a simple question, it sort of bounces off the edge. It can give you a simple answer. But if you ask it a very specific, detailed question that has all sorts of characteristics, which we'll get into in a second, it's forced to burrow in deep somewhere into its knowledge in order to get the answer, right? So you have to find a more specific space inside of the weight structure or the weight system of this neural network in order to get an answer back out, because it doesn't look like any other question. It's a deeper question. And so prompt engineering is the skill or the strategies of trying to find your way into the right sector of knowledge inside of this into the massive cloud of capabilities. The last piece here is, and I ran into this a little bit more in the CAS exams than on this life exam, where it clearly had no idea what I was talking about, and it made up an answer. There's one question in particular, which is some obscure paper that the CAS was asking its students poor students to memorize and then regurgitate answers on. And GPT clearly had never seen the paper, and it just completely missed on the question. And so, but that's although maybe a little bit of an unfair example, it actually represents a pretty important source of possible expansion of its capabilities, where can you just give it a new body of knowledge, right? Maybe you have seen or heard that Bloomberg has built their own GPT, right? So Bloomberg's got all this information from financial markets. So Bloomberg said, hey, why don't we use our data to build on top of or expand the capabilities of a model, and now we own that model because we own the data. And so the possibility of introducing more domain-specific data to a model using what they call fine-tune training, there's a few different techniques for that, is potentially very interesting. I'll also point out that plugins are another use of introducing data. So this is after the model is built. You can have it access data through API calls, and it can get answers. And I actually have built a plugin, which I'll be talking about in a second. Next slide, please. So we'll talk a bit more about cost of verifying complex output. So, as one way I was trying to sort of cheat here a little bit was to see if I could just get GPT to grade itself. So one of the tried and true techniques of any machine learning engineer I've learned by working with a few of them is the answer to a problem in AI is just more AI. And so go to the next slide, please. So I thought, well, hey, if I'm having trouble grading this is kind of boring. Maybe I can get the AI to grade itself. And unfortunately, it didn't really work. It kind of worked, but it kind of didn't work. It didn't work well enough in order for this to be the answer. So here's an example question from, I think it's CAS 9. And so this is saying, basically it's saying, describe the income statement impact of something you would do, right? I think it's acquiring a company. And in the grading rubric, it said a common error is for the candidate to only discuss balance sheet items. And GPT, sure enough, only discussed balance sheet items in its answer. And then when I gave GPT the grading rubric, so the way this works is I hand it the question, it gives me an answer. I then hand it an answer with the grading rubric and say, how'd you do? Analyze your answer, score it, in this case out of 0.5, and describe why you gave it the score. And so the first quote there is its assessment, where it says, well, there are, so the first quote there is the grading rubric saying there are some common errors in responses, most notably discussing balance sheet items, right? So that was part of the grading rubric I sent GPT, and GPT analyzed its answer against the rubric and correctly noticed that it only discussed balance sheet items. So it said, actually, the answer did not, so the provided answer discusses balance sheet items such as assets and liabilities. Additionally, the response does not demonstrate an understanding how goodwill affects income, which is a requirement for this question. So GPT totally failed on the question, but it gave itself a score of 0.4 out of 0.5. And it's zero, like zero GPT. You just totally screwed the pooch on this question. But it didn't, so it was able to analyze the text and accurately assess the difference between, including, in a value-laden kind of framework. So understand that it made a mistake and what the mistake was, very specifically what the mistake was, but it didn't understand the magnitude of that mistake, right? So next slide, please. So my kind of feeling on this is that it actually is assessing itself on something in addition to the grading rubric. And I think that thing is, how well written is the answer. So I think that's GPT being a language model trained on writing well, was actually really concerned with how well it was writing those answers, as opposed to what the content of the answers were. And so it was very happy to celebrate all of its well-written answers with high marks, even though the content was off in all kinds of ways. So I think there's something very profound here about what a GPT thinks it's trying to do, or what it is trying to do, what it has learned to do, versus some of the things that we want it to do. Next slide, please. This is the chart of the grading. I only did this for the CAS 6 exam because it is a lot of work to set up one of these grading systems. So the blue line is my grade. The red line is GPT's self-grade, and the yellow dotted line is the maximum score for each question. So GPT is very generous to itself. In some instances, I gave it a better score than it got. The weakness is this accounting section. There's like 5 or 6 questions there that really are focused on accounting topics, which, I mean, you folks will know, really arcane, weird kind of like rules. And this is a lot to do with statutory accounting, not even GAAP accounting. On GAAP accounting, it's actually okay. But on statutory accounting, it was just clueless and kind of imported concepts from GAAP, and it was a mess. So it didn't do very well on the accounting section, except when it was asked to analyze and textually analyze some quantity. This goes up, what happens? And it was very good at answering the question using kind of its strong suit. So it never got 0, you'll notice, on any question, which is kind of amazing. But it got 0 on a lot of quantitative questions, and particularly some of the arcane stuff. But that did not slow it down in its own self-assessment. GPT was really proud of its answers because they're all very well written, is my interpretation of what it's trying to do there. Next question, next slide. Okay, so the next one's a prompt engineering kind of topic here. So prompt engineering is a super interesting topic. This is the best kind of summary of what prompt engineering is I found from this Twitter account. It says, where they say that some types of logic are specifically learned and can only be accessed by presenting data to the model in a specific order and specific format. So there's like a magic incantation you have to sort of come up with in order to hand GPT this question, and it will give you back better answers when you do that, which is super interesting. And what I've noticed is that GPT, it can understand qualitatively what a better answer is to one answer is to another, because I saw that it can say this they got this idea wrong or that idea wrong, and I was wondering whether if I could just hand it a bunch, so ask it to answer a question several times in different ways, and just hand those back and say, can you pick the best of these answers, and we'll use that as your grade. So it's my kind of attempt at prompt engineering. Next slide, please. And actually, I'll come back to that. Sorry, I showed these slides backwards, but apologies for that. So I'm going to talk a bit about prompt engineering, and I'll come back a little bit to how I implemented prompt engineering. So the New York Times article, I found one that talked about prompt engineering, and it fairly reasonably well does a reasonably good job of summarizing kind of the state of our knowledge on it. So there's one keyword, act as if. act as if you are an actuary and answer this question. So I use that. Tell me what you need, which is, and thread discussion. So these are two concepts where you keep going back to GPT and you keep saying, okay, you answered the question once, answer it again. You answer it again. And so you're actually, GPT is able to use its prior answer as a jumping off point, and you can modify that answer, even go meta on it and ask it what more information it would want, or ask it to prompt itself better. And so you can use that as kind of an iterative process to dig further and further into the model. And that's what my plan was, as I mentioned a second ago, to try and hand it its answer without looking at the grading rubric. Can I hand you your answer back and you give me another one? And we'll go back and forth a few times and we'll try and pick which the best answer was you give me. My own research has suggested a couple other things. One of them was outline your reasoning. So tell me what you've done and tell me the steps you went through in order to analyze this question. That gives you much better answers to a lot of questions, because it sort of tells you some load of BS. But if you ask it to walk through the analysis of its own answer in real time, step by step, it will give you better answers, weirdly. The last one is is actually another impersonation type prompt engineering trick, which is say the following is a blog post. The assumption there being if what it's learning from a whole bunch of blog posts, and if you structure your question as a blog post, then it's probably going to give you something better in terms of its answer. I didn't find a way to really use that in this, but here's the actual prompt I use. Below is an actuarial exam question. Answer it and be sure to explain your logic each step and perform accurate calculations where necessary. So this is what I want you to do, GPT. Next slide, please. Right, so kind of this idea of hand it a question, right? And then it'll give you the answer and hand it the answer and the question back and say, give me another answer that's better than that answer, and do that a few times. And then you say, okay, GPT, you've got 3 or 4 answers now, just give me the best one. And I'm trying to create a situation where I don't know what the best answer is, but I'm worried that GPT is going to give me a bunch of BS. So I'm just going to tell it to just pick from all of the possible answers that it has generated, which one is the best, and then give me that one. Give me your best shot, GPT. And it just didn't really work. Again, we ran into this problem where GPT can qualitatively come up with differences between answers. There probably were answers that were better than others. I have found instances where GPT with some volatility, and I mentioned a few earlier, I give it a question a few times, and it will come up with the right answer sometimes, the wrong answer other times. But unfortunately, we're failing again here on it not really being able to tell which one's the right answer. Next slide, please. So the next, we're going to go through these pretty quickly, but one of the things that I mentioned was 2 things here. 1, limit on its knowledge, and 2, limit on its ability to calculate things. Now, luckily, we have other ways of embedding knowledge inside of software that aren't GPT. we have all kinds of software programs and APIs we can use. And so why don't we just give GPT access to these other software programs and then allow it to figure out for itself what it should use and how to use it. So next slide. So I wrote a plugin access for GPT, which I applied for, and there's a Python API that a friend of mine wrote for a property catastrophe reinsurance pricing package. And so once I plug that package into GPT, I can say I want to price some reinsurance, and then it knows all the parameters that it needs in order to price a reinsurance program, right? I can help you with that. Next slide, please. And so I specify some of the requirements, and there's some defaults in there, and it can interpret properly the output that comes out of this program. And so I can actually use GPT with access now, because it would never be able to do this without access to an external resource that allows it to price some reinsurance program. Next slide, please. And then now I can say, modify that, now use a weighing distortion function, right? So whatever that is, next slide, please. And I actually do say, I don't know what that distortion function should be. What should it be? And then it gives me a pretty comprehensive analysis of how to pick a distortion function for reinsurance pricing. You don't need to know what that is, but I can tell you that this isn't bad. So I didn't tell GPT any of this. This is GPT pulling in its general knowledge to then tell me how to pick a distortion function. So here we're doing something really interesting, right? We're actually selecting an assumption using GPT's textual analytical capability. which then we can feed into an API that will do all the calculating for it, right? So GPT only needs to make the decision about what assumption to make, and then somebody else can do the work, right? Being another API. Next slide, please. This is a cool one. So this is one where, hey, I don't know what the severity distribution should be. So can you just fit one for me? And she was like, yep. Oh, I noticed that your data is skewed. And so here's a few distributions you might pick from. Next slide, please. And I can say, okay, well, let's do log normal. And, here's some kind of things I can do with the log normal. You should do the log normal. And it accurately calculates the mean, the coefficient of variation. And then by itself just runs the API and comes up with an answer. Next slide, please. So kind of run a little faster. I want to save some from questions. So here's another thing I was excited about. I'm trying to merge different domains now, right? Because what I believe is happening is that GPT is very good at textual analysis. It's very good at what's called strategic analysis, data analysis strategy, maybe even more grandiose versions of strategy. And you have to present the information to it in a way that kind of cheats a little bit to get the answer you want. And so what I wanted to do was try and imagine if GPT could assume the persona of a sales manager and an actuarial manager talking about a new product idea. And Screenplay by Oliver Stone is the way that I chose to ask GPT to present this information. So you think about if you're in a company and you're trying to just figure out, should I launch a new product? We have real companies organized. You have different domains. They represent different bodies of knowledge, right? And they have a conversation which integrates their bodies of knowledge to create the right answer for the company, right? And so there's necessarily a textual interaction, which is the spoken word represented by the screenplay concept. And then we want GPT to use two sections of its knowledge to then have them collide and integrate, right? Which is another thing we know that it's really good at doing. Next slide, please. And here's what I came up with. So I'm going to read a little bit of this. You can see the screenplay here, Oliver Stone. Probably not a very good movie. This one would be, but we have Celine and Mary. And so Celine presents the idea. Mary says, interesting concept. We need to consider this feature will affect overall profitability. Celine says, I understand your concern. And then Celine, very interestingly, says, oh, hey, last year, our competitor implemented this and sales skyrocketed. So this would be like an interesting, here's also limitation and opportunity, I think. So a lot of data that companies use to make decisions about products or whatever comes from inside the company, right? So there's no data that GPT is going to be able to use in order to actually make this determination. I don't care how much training you do for the model, it won't ever access kind of the competitor data in the form that a company would want for it to make decisions. But that company does have that data. And in principle, there's not a reason why that company couldn't expose an API to GPT that would just hand it the data. Again, you want to wall it off from the privacy concerns and proprietary data. We don't want that getting up back into the model. But GPT could just say, oh, hey, you want data? I'm going to access this API, go get the data. And now we can have a conversation with myself about the conclusions that data suggest, right? So, and this is how executives make decisions as well. We talk about our experience. We say, oh, I saw this happen in my career once. And this is some data that supports that as a generalization for what can happen in the future. So here's how we should make the decision. And so the limitation of this form here, in my mind, is very much about the data. And the data is not data that we're going to get by fine-tuning the GPT model on open source information. The data here is data that we're going to need to access from another form, the way in which humans process this data, which is through proprietary access to knowledge inside of a company. So it's both encouraging in the sense that I think GPT could handle that data, but it's a challenge because the company is going to need to be able to build the capability to give GPT that data in order to capitalize on its abilities here. Next slide, please. Okay, in summary. So I will put it this way. Here's the way my conclusion, what I think about GPT, which is it has analytical ability. And the way I think of that is it has created decision-making models that are inferred from text. Whether we know it or not, the way that we speak and the way that we write to each other contains, embedded within those communications, analytical and decision-making models, which GPT can actually extract and give back to us, even though it's not in a formal kind of sense, but that is what it has done. It has been able to model a lot of human decision-making and human communication. Plugins, a lot of other limitations here are limitations that humans have as well. Plugins will help with complex modeling, as with humans. Additional data sources will help with analytics, as with humans. There are deep problems with iterating on complex questions, as with humans. So you think of actuarial exams as wrestling with this very problem, which is saying, how do you train an actuary? How do you know if this actuary knows what they're doing? We'll give it a whole bunch of difficult questions on an exam and see how it does. And that will prove to us that this actuary or this candidate can be an actuary. One last thing, and we'll come to a couple questions, or we get a few questions, which is awesome, which is my feeling is that high quality analysis will become cheaper as a result of this. And that doesn't mean that everything goes away, right? It means there's going to be scarcity that will pop up somewhere else in this analytical tool chain. One of the sources of scarcity today is how many actuaries do we have that can perform all these kinds of analyses. I think there's going to be other forms of scarce resource and ability to make good insurance decisions. One thing that I've noticed about this, on a positive note for actuaries, is that it takes an actuary to tell when GPT is full of BS. So you can imagine this technology being a complement in the economic sense to actuarial skills, because for the questions that really matter, maybe we all start from the baseline of a GPT answer, and then you're going to have some very experienced, very effective actuaries who are going to be able to tell the non-practitioners what is real and what is not. And so it's possible that the value of actuarial services will go up, although access to actuarial and analytical tools may also go up dramatically. That is my presentation. Couple minutes left. I have a few questions. I don't know, Richard or anybody else, the administrators here, if we're okay for a couple minutes.
Yeah, David, feel free. If you'd like me to go through, if you want to go ahead and address some.
Yeah, so Transformer, I sort of didn't do a very good job of that. Sorry, you'll have to look that up. I don't really want to mislead people. It's not my domain. Use his phone to look up the answer in Reddit. Possibly, that's something it can do. It has to analyze Reddit information. And that's one of the interesting limiting things that might emerge is, does GPT or future versions of these models have access to all data online? In Japan, there was a ruling which said models can train on all data. There's no ownership there. That's super interesting. Were exam syllabus materials available to GPT? Yes, anything online is. I haven't seen actuarial syllabi enlisted in any of the kind of large language model training sets, but it could very well have access to that information. We don't know what is involved in structuring the data so that it can be ingested. A lot of the actuarial syllabus materials are in PDF form, where you have to like take that PDF and make sure you're kind of deconstructing it in a way that makes sense, which, for those of us who try to do that, as I've been doing for these exams, is, it's not totally straightforward. You can get some errors in there. So I'm not sure how they feel about that, but certainly GPT could study past exams. This is, in terms of GPT, how they get them to use an exam, I have no idea. I guess you sit down with paper and pencil, you can have them not write an exam. That's the last question, Sarah. But for Glenn's question, so I want to kind of talk about this for a sec, just a sec, 2 minutes, less than 2 minutes. What's the point, right? And as I think about what the point of all this is, it's interesting that maybe GPT could be trained to pass an exam, right? But is that what we really want? Like, do we want a AI that can pass exams? That's not what I want. I don't particularly care. I'm not taking any exams anymore. What I really want is I want an AI that can help me with my job, or be successful, or my company, or people who report to me. And there, I think it's worth spending a fair bit of time thinking about, is the application, are we training it on the right kind of problems? Because actuarial exam questions, although they're as good as we've got right now for training actuaries, maybe GPT gives us an opportunity to change the way we train actuaries, or maybe we train a GPT-style actuary differently than we train human actuaries. Maybe we want to have it specialize in different kind of analysis. So yes, it could study past exams. We could use that as a fine-tuning training set. But I would pause to think a little bit about, what's our goal? And maybe that would influence what we might give it to train for what jobs we might want it to do. So that's it. Alex, back to you.
Awesome. David, thank you very much.